Hello everyone, welcome to Math 112 Linear Algebra. So i-discuss natin yung first module which is entitled Linear Equations and Matrices. So first will be a review on systems of linear equations na na-discuss nyo na sa algebra. And second is about matrices and row reduction of linear systems. Okay. So first, linear equations, yung definition. A linear equation in n variables is an equation of the form a sub 1 x sub 1 plus a sub 2 x sub 2 and so on up to a sub n x sub n equals b, where x sub i's are variables, a sub i's and b are constants, and not all a sub i's are 0. So for example, we have ax plus b equals 0 is an example of a linear equation of one variable. We have linear equation in two variables and linear equation in three variables. A system of linear equations or a linear system in n variables is a finite set of linear equations. For example, we have a linear system here of three variables, and we have a finite set of linear equations. We have three linear equations here. A solution to a linear system in n variables is an n-tuple which satisfies every equation in the system. A solution set consists of all such n-tuples. Yung solution set, ito na yung collection ng mga solutions natin. The variables in a linear system are referred to as the unknowns. A linear system which has no solution is called inconsistent, and the one with at least one solution is called a consistent system. So in solving systems of linear equations, the easiest way is to write each equation in standard form. So pag para yung mga variables natin, naka-align sila in vertical columns. Then, so proceed tayo ngayon sa mga technique ng pag-solve ng linear systems. To find solutions, gagamitin natin yung method of elimination. So we eliminate some of the unknowns by adding a multiple of one equation to another equation. So yung goal natin dito is mawala yung some unknowns, ibang unknowns, to solve for one unknown, then i-transform ulit natin yung equations para makuha natin lahat ng solutions natin. Okay, so each step in the transformation process is accomplished by repeatedly applying one of the following elementary operations. First, we can interchange the position of two equations in the system. Second is we can multiply an equation by a non-zero scalar. And third, we can replace an equation with the sum of itself in a multiple of another equation in the system. For example, let's try to solve number 1. So let's solve the system. X plus 2y equals 8. 3x minus 4y equals 4. So let's name the two equations as E1 and E2 for equation 1 and equation 2. E1 and E2. So first, ang gagawin natin is we want to eliminate one of the variables to solve for the other. Okay? So ang gagawin natin, suppose we want to eliminate x, then solve for y. So, kailangan yung coefficients ni x ay parehas or negative na isa. So, halimbawa kung ito si 3x, ang gusto ko dun sa kabila, either 3x siya or negative 3x. So, gagawin natin is, gagamitin natin elementary operations. So, we will multiply the first equation e1 by negative 3. So, we multiply negative 3 to e1 and we substitute that to e sub 1. So, yung system na natin, so yung baba, same pa rin. Yung taas, mag-multiply tayo ng negative 3. So, we have negative 3x minus 6y equals negative 24. Okay? Next. Next, i-add natin yung dalawa. Then, yung result natin, ilalagay natin siya kay E2. So, we add E2 and E1. Then, we put the result in E2. Actually, kahit saan. So, what happens here, yung first equation natin is still the same. So, E2 plus E1 now. So, pag i-add natin, magka-cancel yung negative 3x and 3x. So, we have negative 10y equals negative 20. Next. So, yung second equation natin, pwede tayong divide by negative 10. So, or multiply by negative 1 over 10. Multiplying by a scalar. So, we have negative 3x minus 6y equals negative 24. So, ay y equals 2. Okay? So, pwede din nating i-simplify yung equation 1. Since pwede tayo mag-divide ng 3 or negative 3. Multiply negative 1/3 e1 to 1. So, yung system na natin here is x plus 2y equals 8 and y equals 2. Okay. So, ngayon, isa-substitute natin yung y dun sa first equation. So, we have x plus 2 times 2 equals 8. So, 2 times 2 is 4. Then, transpose. So, we have x equals 8 minus 4, which is 4. So, x equals 4 and y equals 2. So, ito yung solution natin for the given system. Okay? So, we can write the solution as pwede siyang ordered pair for 2 or just ganito. X equals 4, y equals 2. Okay. So number 2, system of equation in 3 variables. Same din yung process, mas mahaba lang siya dahil 3 variables siya. Then instead ng ordered pair, may mahanap kayong ordered triple kung nag-exist yung solution niyo. Okay? So yung method of elimination, so lahat ng mga systems, linear systems na na-generate natin using any of the elementary operations, equivalent lang siya doon sa yung original na system natin. So if any one of the 3 elementary operations is performed on a given system of linear equations, an equivalent linear system is obtained. Okay. Another example. Suppose that the 3 points, negative 2, 8, 2, 6, and negative 7, 3, lie on the circle x squared plus y squared plus dx plus ey plus f equals 0. Determine a linear system of 3 equations in 3 unknowns that must be solved to find d, e, and f. Then solve the linear system obtained for d, e, and f. Okay. So, given tayo ng 3 points, tapos yung equation, kailangan natin gumawa ng 3 equations in 3 unknowns. So, yung first equation natin, pwede natin gamitin yung isang point. So, ito si x, ito si y. So, we have negative 2 squared plus 8 squared plus negative 2d plus 8e plus f equals 0. So, sinubstitute natin yung x and y na components dun sa equation natin. So, next, para makuha natin yung dalawa pa equations, gagamitin naman natin yung second and third points respectively. So, yung second equation natin, we have 2 squared plus 6 squared plus 2d plus 6e plus f equals 0. And last, we have negative 7 squared plus 3 squared minus 7d plus 3e plus f equals 0. So we can simplify this into negative 2d plus 8e plus f equals negative 68. 2d plus 6e plus f equals negative 40. And negative 7d plus 3e plus f equals negative 58. So, ito yung linear system natin of 3 equations in 3 unknowns. Yung unknowns natin ay sina d, e, and f. Okay, so yung solution nito, this is left as an exercise. So, parang ganyan siya dun sa last example kanina na 3 equations, 3 unknowns. So, solve na siya. Okay. So, ang isang linear system, hindi siya laging merong solution. So, ang linear system can either have a unique, sabihin isa, or indefinitely many, or no solutions at all. Okay? So, yung previous example natin, meron tayong unique solution. Iisa lang yung possible solution niya. So, tingin naman tayo ngayon ng example ng isang system na magkakaroon ng infinite number of solutions. A manufacturer makes 3 different types of chemical products, A, B, and C. Each product must go through 2 processing machines, X and Y. The products require the following times in machines X and Y. Okay. 1 ton of A requires 2 hours in machine X and 2 hours in machine Y. 1 ton of B requires 3 hours in X and 2 hours in Y. 1 ton of C requires 4 hours in X and 3 hours in Y. Machine X is available 80 hours per week and machine Y is available 60 hours per week. Since management does not want to keep the expensive machines X and Y idle, it would like to know how many tons of each product to make so that the machines are fully utilized. It is assumed that the manufacturer can sell as much of the product as it is made. Okay? So, meron tayong two equations na mangyayari since isa for x, isa for y. Then, meron tayong tatlong knowns or yung variables dito. Okay? So, like 3 different types of chemical products. So, yeah. So first, let A be the number of tons of chemical A, and so with B and C, then gumawa tayo ng table natin. Okay, so for chemical A, sulat na natin lahat. Okay, so we have 3 chemicals and the number of tons na lang. Yung X and Y, so yung time needed natin kay machine X, tapos time needed natin kay machine Y. So si chemical A, babalikan natin yung problem natin. Si A, 2 hours kay machine X, 2 hours kay machine Y. Si B ay 3 hours in X, 2 hours in Y. Si C ay 4 hours in X and 3 hours in Y. Okay? So ito ay 2 hours. Ito ay 2 hours din. 3, 2, 4, 3. Then, si X, ang total natin na possible hours ay 80 hours per week. Tapos si Y ay 60 hours per week. So, ibig sabihin, dapat yung machine X natin, yung total number of hours niya ay 80. Okay? So, pag gagawin natin siya ng equation, so yung kada ton ay 2 hours. So, 2A. Then, ito ay 3 times 4. So, 2A plus 3B plus 4C is 80. Ito yung number of hours kay machine X. Okay? Then, si Y ay 2A plus 2B plus 3C equals 60. Okay? So, we have E sub 1, E1, E2. Okay? So, solve natin ngayon yung equations natin. So, first, pwede natin i-eliminate yung A. We have natin E1 minus E2. Nilagay natin kay E2. So, si E1 ay same pa rin. 2A plus 3B plus 4C equals 80. Ngayon, si E2 ay B plus C equals 20. So, yung B natin is equal to 20 minus C. Then, substitute natin ngayon dito sa E1. Meron tayong 2A plus 3 times 20 minus C. So, 20 minus C. So, ito ay 60 minus 3C. So, may iwan ay 2A plus C. Meron tayong 2A plus C equals 20. Tapos, meron tayong B equals 20 minus C. So, in terms of A, yung task natin ay A equals, so transpose si C, tapos divided by 2. Tapos yung B natin ay 20 minus C. Okay? Next. So, si C natin, magkakaroon tayo ng restriction na si C dapat ay greater than 0 or equal and less than 20. Kasi since number of tons yung dinideal natin dito, hindi tayo pwedeng mag-negative number at hindi tayo pwedeng lumampas where si B nga ay 20 minus C. So kapag si C ay 20, wala na tayong B. At pag lumampas tayo ng 20, magne-negative si B. Okay? Then, so yung solution natin is kung si C natin ay equal to some number na R, si B natin ay 20 minus R at si A natin ay 20 minus R over 2. Okay? So, ito yung solution set natin. Okay? So, madami tayong possible solutions. For example, if R is 10, then yung A natin ay 20 minus 10 is 10 divided by 2 is 5. Yung B natin ay 10, then yung C ay 10. Okay, so any solution na nasa-satisfy yung so si R ay real number, then masasatisfy yung restriction natin. Yun yung mga solutions natin. So madami tayong possible solutions. Meron tayong infinite number of solutions. Okay. So yun lang yung kailangan natin. Wala tayong mahanap na best solution dun sa mga solutions natin unless magdadagdag sila ng other restrictions. For example, ano yung distribution or solution na magbibigay ng maximum profit or minimum profit, mga ganong other restrictions. Pero since hinanap lang natin is yung solution set, so ito lang yung sagot natin. Okay. So the general solution of the previous example can be written in terms of a parameter. This parameter is any real number assigned to a variable so that every other variable is expressed in terms of this variable. So, sa previous example, ginamit natin si R. Okay? So, tingin tayo ngayon ng isang inconsistent system. So, we have this system, then pag gumamit tayo ng elementary operations, let's say gusto nating i-eliminate si x doon sa E2 and E3. Then we have this. So makikita niyo yung dalawang equations, si E2 at si E3. Meron tayong 5y minus 4z equals 0 and 5y minus 4z equals negative 2. So pag gagamit tayo ng operation na eliminate natin yung isa, magkakaroon tayo ng 0 equals negative 2, which is impossible. So therefore, this system has no solution and it is an inconsistent system. Okay? So, yung sa linear equations, systems of linear equations natin. So, we now go to matrices and row reduction. So, let's look at definitions. An M by N matrix A is a rectangular array of Mn real or complex numbers arranged in M horizontal rows and N vertical columns. The ith row of A is given by A sub I1 up to A sub IN, where 1 is between I and M. So, example, pag first row, meron tayo A sub 1, 1, A sub 1, 2, to A sub 1, N. Okay? Pag jth column naman, for example, we have second column. So, ibig sabihin, we have A sub 1, 2, A sub 2, 2, up to A sub M2. Okay? So the M corresponds to number of rows and N corresponds to the number of columns. The numbers that appear in each row or column are called the entries of A, and the one on the ith row and jth column is written A sub ij. We call M by N or M times N the size of the matrix. So matrix notation we denote a matrix by A or by writing its size, the dimensions, or we have bracket notation. So for purposes of discussion, we will use the notation in terms of entries. Okay, so A equals A sub ij, where 1 is between I and M, and J is between 1 and N. Okay. Two matrices A and B are equal if and only if A and B have the same dimensions and A sub ij equals B sub ij for all I for all j. So, equal ang dalawang matrices pag lahat ng entries nila ay equal at same yung positions. Okay. Matrix addition. Pwede tayong mag-add ng dalawang magka-size na matrix and yung sum nila ay yung sum lang nung corresponding entries nila. Also, pwede tayong mag-multiply ng isang scalar sa isang matrix, and yung effect niya is lahat ng entries ng matrix ay mamumultiply by that scalar. Okay? Scalar is a number. Transpose ng isang matrix ay magpapalit lang yung rows tapos yung columns natin. So, halimbawa meron tayong 3x4 matrix, magiging 4x3. 4x3 siya. Then, yung mga row entries, magiging column entries. And yung mga column entries ay magiging row entries siya. A 1x(n) matrix is called a row vector. And an n/1 matrix is called a column vector. The dot product of two n vectors, so a row vector and a column vector, is given by a dot b is equal to summation of a sub I b sub I from 1 to n. So dito, meron tayong 1/n multiplied by n/1. So we have a 1/1, which is a single number. Yun yung dot product or inner product natin. Okay. Next is matrix multiplication. So meron tayong m by p matrix at p by n. So para makapag-multiply tayo ng matrix, dapat yung number of columns ng first matrix ay equal sa number of rows ng second matrix natin. So for example, meron tayong 3x4 and 4x5. We can multiply those two to make a 3x5 matrix. Pero kung 4x5 by 3x4, hindi siya pwede. O hindi siya. Pag baliktad, sometimes hindi siya pwede kung hindi nagko-correspond yung dimensions niya. Okay. So example, is an example of transpose of a matrix. So yung row natin naging column, yung columns natin ay naging rows. Okay. Next is matrix multiplication. So we have a 3x2 and a 2x3 matrix. So we have 3x3 matrix. So paano nakuha yung entries niyan? So yung first natin dito, since nasa first row, first column siya, sub 1, 1, gagamitin natin yung first row and yung first column. Okay? Then, i-multiply natin yung corresponding entries na. So, we have -4 times 1 plus 5 times -3, which is -4 minus 15, which is negative 19. So, nakuha natin yan. So, yung next, this is first row, second column. So, now we have first row and second column. So, ito naman ay negative 4 times 2 plus 5 times negative 2, which is negative 8 minus 10, which is negative 18. And so on. So, na-complete natin yung matrix natin. Another example, meron tayong 3 by 4 and 4 by 2. So, magkakaroon tayo ng 3 by 2. So, ito ay 3 by 4. Ito ay 4 by 2. So, yung resulting matrix natin ay 3 by 2. Okay. More definitions. An m by n matrix is called square matrix if the number of rows is equal to the number of columns. A square matrix is a diagonal matrix if A sub ij equals 0 for every I not equal to j. So, sinasabi lang yan, diagonal matrix kapag ang entries lang ng matrix mo yung sa diagonal niya, yung main diagonal niya, yung may entries siya tapos yung mga other entries natin ay 0. So, magkakaroon lang ng non-zero entries ay yung sa main diagonal. Yung diagonal matrix. A square matrix A is upper or lower triangular. Upper triangular if A sub ij equals 0 for I greater than j. And lower triangular if A sub ij equals 0 for I less than j. Pag sinabi natin upper triangular, yung bottom half, yung sa baba nung main diagonal niya ay 0 lahat. Pag lower triangular naman, yung taas ng diagonal ay 0 lahat. A diagonal matrix A is called a scalar matrix if A sub ij equals C for every I equals j. So, scalar matrix siya. Pag diagonal matrix siya na same lahat ng entries nung nasa diagonal. A square matrix is called a symmetric matrix if the transpose of A is equal to A. So, for example, this is a square matrix since we have 3 rows and 3 columns. The number of rows equals the number of columns. We have an upper triangular matrix where yung lower half ng diagonal ay 0 lahat. So, ito. We have a diagonal matrix. All other entries except for the main diagonal are 0. Symmetric matrix. When we get the transpose of symmetric matrix, we get the same matrix. And a scalar matrix, we have a diagonal matrix with same entries in the main diagonal. Okay. So let's look at properties of matrix operations. For all m by n matrices A, B, and C, so we have properties of matrix addition. A plus B is equal to B plus A. So this shows commutativity. Next property is associativity. A plus B plus C is equal to A plus B plus C. Third, there exists a unique M by N matrix O such that A plus O equals A. So, yung matrix O natin or zero matrix, pag in-add natin siya to any matrix A, we still get A. Okay? So, it is a unique matrix since siya lang yung maka-satisfy nitong condition ito. For all A, number 4, for all A, there exists a unique matrix negative A such that A plus negative A gives us zero matrix. Next, we have properties of matrix multiplication. For all matrices A, B, and C of appropriate dimensions, we have the associativity property. Next is the distributive property and identity property. So, kung kanina sa addition, we have zero matrix. So, ito naman yung identity matrix natin for multiplication. So, pag we multiply this to any matrix A, we still get A as a result. The result. Okay. Next, scalar multiplication. We have the following properties. Again, if we multiply by scalar, we have two scalars. We can multiply the two scalars first from multiplying it to the matrix. Then we have distributive property. We can distribute the matrix to the scalars, or we can distribute the scalars to the matrices. Okay, and number 4, we can rearrange them. We have two matrices A and B and a scalar R. We can multiply the scalar to one of the matrices first, or we can multiply the two matrices first before multiplying by the scalar. Next, we have properties of transpose. The transpose of the matrix A is A. And we have A plus B transpose equal to A transpose plus B transpose. A times B transpose is equal to B transpose times A transpose, and R A transpose is equal to RA transpose without the parenthesis. Okay? So, yan yung mga properties of matrix operation. So, this study the properties, and kung may questions kayo about sa lecture, about sa module, about sa exercises, i-contact nyo lang ako through Messenger. Okay? So, thank you for listening and see you next time.